So section 11.3 is going to continue our work on conic sections. This one's going to be a hyperbola. Now, hyperbola kind of looks like two parabolas that face away from each other. So there's a little bit of vocabulary I want to teach you about it. But first, let's kind of see where you might encounter the shape of a parabola. Not quite as many applications that I'm aware of as the parabola, but for hyperbolas, there's the basic shape. Now we're going to end up drawing this kind of scaffolding here that you see, this rectangle and these diagonals. But the basic shape is just the two blue curves there. So where might you see that? Yes?
In mirrors, like...
In mirrors?
Like camera mirrors, like old school
I know they do
no?
use hyperbolic lenses for certain types of applications, but I can't tell you off the top of my head where those would be. But here's one. You'll see this if you visit the Fermi 2 plant here in Michigan. And any nuclear cooling tower has, those nuclear cooling towers are a hyperbola rotated around an axis, and that's where they get their shape. You'll see that same kind of shape if you see a high explosion of energy, like a mushroom cloud. Doesn't have to be a nuclear explosion. Hopefully it's not. Before we had GPS, we had LORAN. And what LORAN was a series of beacons all around the Earth that would emit a signal at a regular rate. And you could find where you were by looking for the intersection of two hyperbolas. That's being allowed to die kind of slowly because GPS is much better. If you're traveling faster than the speed of sound, then you're going to leave behind you a sonic boom, which will intersect the ground in one branch of a hyperbola. And I always thought this picture was kind of cool. It's the moment that a plane is breaking the sound barrier. So kind of cool stuff. Dulles Airport in Washington, designed by the architect who designed the Arch of St. Louis, has a hyperbolic shape for its roof. The Kobe Tower in Japan is a hyperbola rotated around an axis. And I'm not sure about the Impression 5 Science Center, but these things, I don't know. They look like hyperbolas rotated around an axis. I'm not sure. If someone wants to find out, I'd be happy to know. What's that? Yeah, those are the ones you do the coin trick in. Yeah. It's kind of cool, especially when it gets down towards the bottom. It's kind of fun to watch. In any case, our goal is going to be to graph these things. So let me open up this link here. And you can open up with the QR code there. Some vocabulary. Let's talk a little bit about the vocabulary regarding hyperbola. And one thing you're going to need to be aware of is what's called the transverse axis. Transverse axis is just this axis that goes from one vertex to the next. And in a similar way, we're also going to work with the conjugate axis. The conjugate axis is this one, perpendicular to the transverse axis. Now, both of these axes are formed by connecting these 4 points with a rectangle. Now, that rectangle is made up of the points that you would get if you were graphing an ellipse, but we're not graphing an ellipse. How can I tell that the equation that I have here is not an ellipse? What's different about that? Yeah, you got a subtraction sign here. So because of that subtraction sign, things are going to look a little bit different. They are a little different. Can anyone suggest an idea on how to rewrite this? Think back to what we did with ellipses. How could I start out by rewriting that?
X squared over 2 squared.
Mm-hmm.
And then minus y squared over 4 squared equals 1.
Perfect. So I'm going to do 2 things. First of all, rewrite it like that you suggested. And secondly, ditch this pen. Heads up, Antonio. No. Nah. Can't say nothing but net because I wasn't even close on that one. All right. So here we go. We've written it, the way we did with our ellipses, and that's great. What you're going to start out with in terms of graphing these hyperbolas is you're going to graph a couple points in the x direction. So you're going to move 2 spaces to the right and 2 spaces to the left, matching your denominator here. And then we'll do the same thing in the y direction. You're going to move up 4 and down 4. And what that does is it allows you to draw this little rectangle here. And through that rectangle, you're going to draw a couple lines. These lines are going to be your asymptotes. These are things that I want to see on your exams. And I'd be really appreciative if you use a ruler. In fact, if you want to borrow a ruler, I've got some right here. So help yourself. Yes?
Are we just graphing, I guess, the first 2 points? Well, the first 4 points. I
So
guess, where the vertex would be, where the vertices
yeah,
would be. If we
these,
graphing a-
that's exactly what this is. These points are the points you would graph if this was a plus and you were going to connect this with a nice oval called an ellipse. It's exactly the same points. Except instead you're going to draw this box, this rectangle, and through that rectangle you're going to draw the diagonals of the rectangle. So these lines right here. Now, if you've drawn things correctly, these lines should pass directly through the center. So let's see that they do. And cut yourself a little bit of slack if you're doing these things, you know, kind of by hand, etc. It could be off a little bit, but they should be pretty close to the center. If they're not, make sure you didn't overcount one way or the other, up or down, left or right. Now the last thing to do is to realize which way this is going to open. There's a couple possibilities here. So once you've drawn your rectangle and asymptotes, then we need to fill in the rest of this graph. Now there's 2 possibilities here for us. If you have, say, x squared over a squared minus y squared over b squared equals 1, that's going to open left and right. What else could happen? Well, you could have y squared over a squared minus x squared over b squared equals 1. Which way do you think that's going to open?
Up and down.
Yeah, opens up and down. So in our particular case, which way is this going to open? Left and right or up and down? Yeah, left and right. Thank you. A couple voices on that. Appreciate that. So left and right. So let's draw basically a parabola. Now the parabola is only going to touch right here where that blue dot is. That's going to be the vertex. Everything else is just trying to help us draw what this looks like. So this graph's going to get close to, but never quite touch these diagonals. Those diagonals are asymptotes. So it gets close to them, and it's kind of like a guide. Now the nice thing about drawing these diagonals here is that means we don't really have to plot points. I'm not interested in seeing you graph points. I just want basically this shape. All right. So how's that one looking there? Doing okay? There's a couple places and a couple mistakes that people typically make when they're graphing these things. Sometimes people are really anxious about, touching these things, and they know it's supposed to get close, so they'll do something like this. They'll just do that. They'll just kind of trace it. And that's not so good. Another thing that people do is they're afraid of touching it, so they kind of like curve away from it. That's not so good either, because these lines are supposed to get close to this one. And I suppose the last thing that I see people do is instead of having a vertex here, people come all the way into the center. And again, that's not so good. So I am going to be a little bit gracious about grading these things, but these kind of mistakes, well, those aren't so good. So avoid those kind of mistakes when you're graphing things. Now this is another conic section. And kind of like ellipses and parabolas, it's going to have foci. Foci, of course, is plural of focus. So where are we going to find the foci? The foci are going to lie a distance of C away from the center along the transverse axis. Now what's C? How are you going to calculate C? C is going to be calculated from C squared equals A squared plus B squared.
Wait, should it be A squared minus?
Ah, great question. Where was A squared minus B squared used? Finding this foci for an ellipse. So with a hyperbola, it's different. Now with a hyperbola, your foci should lie inside each branch of the hyperbola. So if you make a mistake and accidentally use a C squared as A squared minus B squared, you're going to probably end up with foci inside the rectangle as opposed to inside each branch of the hyperbola. So it's a nice way to double check yourself if you graph it and look at it and go, wait a minute, that doesn't look right. If that's the case, go back and fix it. So let's figure out what C is for this particular one. So in our case, we're going to get C squared equals 2 squared plus 4 squared, which of course is 20. So C would equal the square root of 20. Nice. Well, you can do the plus or minus. Doesn't matter, because you're going to move a distance of the square root of 20 to the right of the center, which is at 0, 0, and to the left of the center. Now square root of 20 is going to be 4 something, so it's going to be a little bit less than 5. Let me write it like this. Square root of 20 and 0. And then over here, negative square root of 20 and 0. Those are going to be your foci. Call them F1 and F2 if you'd like. Those are the exact coordinates of your foci. So, nice. So I think we've got pretty much everything. There's one last thing that I could ask that sometimes you do get asked, and that would be for the equation of the asymptotes. Before I move on to that, are we okay with what we've got so far? Got a nod from Josh, sporting that cool Michigan Tech hoodie. Well done. Let's see, looking good? All right. So let's figure out the equation of the asymptotes. Now there's a couple ways I'll show you how to do this. I'll show you another one in section 11.4 where it becomes a little bit more critical. But for right now, I know the general shape of this equation. The reason I know the general shape is because of its y-intercept. What's the y-intercept? 0. Now typically speaking, we have equations of the form y equals mx plus b, but I'll just write it as y equals mx because b is 0, right? It's going through the origin. So all I need to figure out then is the slope. Slope is the rise over the run. Well, the rise up here is what? 1, 2, 3, 4. And the run is 2. So the rise over the run is 2. M equals 4 over 2. So this line is y equals 2x. And this line is just going to have the negative slope there. Y equals negative 2x. And that's it. You're done. Okay. Looking good on problem number A. Any other comments or thoughts on that one before I move on to example B? Yes, please.
Will it always, when we're drawing our asymptotes, will they always go through the origin? Or
No. But in this section they will. In section 11.4 we're going to move away from having 0 as a vertex or 0 as the center. So in 11.2 our ellipses had a center of 0, 0, and in 11.1 our parabolas had a center, or excuse me, a vertex at 0, 0. So, yeah, we're going to make this a little bit more general. Yep. So, good question. Let's try example B. Example. So we've got y squared minus x squared over 25 equals 1. How do I know that this is a hyperbola? How come it couldn't be like a parabola or an ellipse? Got a minus, good. You got two squared terms, one of them's positive, one of them's negative. So it's going to be a hyperbola. If you had two squared terms and they were both positive, it'd either be an ellipse or a circle. If you have one squared term, then it's going to be a parabola. All right. Probably want to rewrite this. So, Pfeiffer, suggestions. Any way you think we could rewrite this?
Y squared over 1 squared.
Yeah. We'll think of this as being y squared over 1 squared minus
X squared over 5 squared.
Thank you so much. X squared over 5 squared. Good deal. Antonio, which way do you think this one's going to open?
It's going to open up and down.
Yeah. So because of this y squared term is positive, it's going to open up and down. Well done. Opens up and down. All right. So let's flip over to our next page then and graph it. So you're going to start out at your center, and let's see, let me color coordinate them this way. I'm going to move up 1 and down 1. That's going to give me a couple points. In the x direction, I'm going to move to the right by 5 and to the left by 5. Now, a lot of you taking the rulers, and that's great. You would then draw your box with those rulers and then draw the diagonals of the box. So let's put in the diagonals for ourselves. I'm just going to make these a little bit darker. There and here. I would suggest that for the exam on this material that you kind of keep in mind some of the places that I've discussed where you use the shape of a parabola, ellipse, or hyperbola. We've talked about a lot of the applications there. This one's going to open up and down, so let's take care of that. I've got something like this. So very wide opening hyperbola. My apologies for any vertigo here. And there's one last thing we're going to need to calculate. I'm not sure it's going to fit on our graph all that well, but we'll calculate it anyways. We need to find the foci. So for our foci, let's see, foci, I need to calculate C. So C squared is going to equal A squared plus B squared. Okay. Looking all right there. So 1 squared plus 5 squared. So what does C equal? Square root of 26. Now square root of 26 is going to be 5 something. And like I said, I don't think I have quite enough slack in this one to exactly draw that. I'm just going to put a couple of spots up here and here. Heva, what would be the coordinates of these points above and below our center? This one. I'm going to move distance of C away from the center. So I'm going to move up the square root of 26. 0 and square root of 26. Perfect. 0 and negative root 26. Great. Ellie?
How do we know that it's on the y-axis and not the x?
Great question, because you had a positive y squared term when we had it in our standard form. Even if I mix this up, if I rewrite it as negative x squared over 5 squared plus y squared over 1 squared, it's your y squared term is the positive one, so that's why it's going to open up and down as opposed to left and right. So good question. Okay, I want to figure out the equation of the asymptotes here. What would that be?
1/5 x and negative 1/5 x.
Well done, Pfeiffer. So if you move over, you've got a rise equal to 1, and then a run equal to 5. So rise over run is 1/5. So this line here is y equals 1/5 x. Rachel, what would the other line be? What would the slope of this one be? Y equals, yeah, negative 1/5 x. Perfect. So we got everything that I could ask for. Looking good on that one. Now in section 11.4, we're going to start shifting things around so that we have a hyperbola with a center at something other than 0. But for now, we're looking good. Cool. Let's do one in kind of an opposite direction. We've got the graph of hyperbola, and this is typically all you see. When you follow along with the stuff that I have on Desmos, that's not always kind of realistic, because realistically when you graph things, you really should only see that. All right, you can put in the foci, etc. Make sure that your foci lie inside of the hyperbola. Okay. Oh, one other thing here. If you accidentally use the wrong formula for your foci, then this is what's going to happen. You're going to end up with foci inside that rectangle. That's telling you, oops, you use the formula for an ellipse to find the foci, as opposed to using the plus, a squared plus b squared, which is for hyperbola. All right, so let's go down here a little bit. Let me shut that one off, and I guess I got to shut one more off. Example C. Well, we'll see. Let me start out this way, asking you, which form is it going to be? Is it going to be this form? Or is it going to be this one? First one or the second one? Second one, yeah. Well done. Because it opens up and down. So the general form of this is going to be y squared over a squared minus x squared over b squared equals 1. Now I don't really take care to put a consistently under x or b consistently under y. I just write them in order. The numerators is what's going to matter. But in order to determine the equation, I am going to need a and b. Can anyone make a little guess or some headway as to what one of those is? Nicholas?
Well,
Nikki?
I see that y squared could be over 12 squared.
Yes, nice. So right here, even though it's kind of tough to see, the coordinates of that point are 0 and 12. So 0 and 12. And then we've got a foci at 0 and 13. So yeah, nice. That's a good way to start. Is that we got y squared over 12 squared minus x squared over b squared equals 1. And let's put that 12 in there. 12. Okay, looks good there. What am I going to do to figure out what b is? Yes?
Can we use our foci equation and solve for b squared since we have c squared?
Nice. This is telling us that C is 13. C equals 13. And we know C squared equals A squared plus B squared. We've already got two of those, right? If you have two of them, you can solve for that third one. So let's plug things in. That's going to be 13 squared equals 12 squared plus B squared. So let me move that over to the other side. 13 squared minus 12 squared is going to be, interestingly enough, 5 squared. So 5 equals B. Nice. Well done. Overall, your final equation should look like this. Y squared over 12 squared minus x squared over 5 squared equals 1. And that's all we're looking for in this one, was to try and find the equation of the hyperbola, and we got it. Nice. Let's try taking a look at problem number D. So another one where we get to reverse engineer things a little bit. This time they've given you the vertices of your hyperbola. And I'm sorry I didn't print this a little bit wider, larger. My bad. I wish I would have, but too late to change that now. In any case, you've got two forms of a hyperbola you could use. Take a minute and decide which one you're going to use based on the information. Now, if you're watching this at home later, hit the pause button and try and decide which form you're going to use. First one or the second one. Don't shout on the answers just yet. Check with your neighbor. Do you agree with your neighbor? Which way does this have to open? Left and right or up and down? So what's the consensus? Left and right or up and down? Left and right. Because your vertices are here and here. So the hyperbola has to open from the vertex to the left and from the vertex to the right. So good job on that. So generally speaking, our hyperbola is going to look like this. X squared over A squared minus Y squared over B squared equals 1. All right. Now let's use the fact that the vertex here is at 0, 1. Excuse me, 1, 0. That's going to tell us a little bit of information about our graph. And we can get some more information this way. Let's see. It's through that vertex that we can draw our rectangle. I can read off this distance here, right? What's that distance? I think it's 1 because that matches your vertice, right? So you're going to go from your center to your vertice. So A is going to equal 1, and this distance here is our B. Now I don't really have a good scale on this. It didn't print out well, so that's all right. But you can figure out how tall you are here, right? How can you figure out how tall you are there?
We have the asymptote.
Yeah, you got the equation of the asymptotes, right? So we've got y equals 3x and y equals negative 3x. So if you're at x equal 1, what's the coordinate of that point? X equal 1, y equals 3. So that means B equals 3. Great, you've got A and B. What's that going to look like for us? Thank you so much. X squared over 1 squared minus y squared over 3 squared equals 1. Beautiful. And then you're not asked to find anything else. You could find the foci if you wanted to, or you're asked to. It's just going to be a distance of a squared plus b squared. 1 plus 9 is 10. Square root of 10 here, square root of 10 there. That would be your foci. All right. Looking good on these. Let's keep going with number E here. Well, what would you do on that one?
Left to right.
All right, this is going to open left and right. That's a good observation. It's going to open left and right. But I'm probably not ready to graph it yet. Ah, well done. So you're going to take this and divide everything by 36. So I'm going to do that on an extra sheet here. Example B. There's probably enough room on the sheet that you have in front of you, but 9x squared minus 4y squared equals 36. Let's take and divide everything through by 36. So good choice on that. Divide, divide, divide. 36, 36, 36. That'll simplify down to x squared over 4 minus y squared over 9 equals 1. And I'll probably rewrite that one last time. X squared over 2 squared minus y squared over 3 squared. Okay. And Antonio mentioned that this opens left and right. So opens left and right. And let's see, what else do we know about this? Well, we can figure out what C is. So, Robert, what would I have to do to calculate C?
C squared equals 2 squared plus 3 squared.
Good. So C is going to be the square root of 13. Nice. All right. Everything's lining up pretty nice. Let's see about graphing this. Now, unfortunately, some of the axes didn't show up too well. One thing that's helpful when you're drawing these things at home and you got to kind of freehand maybe something, try and make your points symmetric in terms of their distances. So, as far as distances are concerned, how far to the left and how far to the right do I have to move in order to find the vertices, or at least the, yeah, what would be the vertices? Yeah. 2 and 2. Now I got to do something similar in the y direction. So that was in the x direction. How far do I have to move in the y direction?
3
Up 3 and down 3. And I'll just kind of keep these sort of color coordinated a little bit. So I'll put these up here in orange. Up 3 and down 3. Here's where I'm trying to be as symmetric as possible. So this is where you're definitely going to want a ruler. I'll provide rules on the exam. Please use them. So let's see. Here. I do want to see these boxes drawn on the exam. The alternative is to plot points. Now you can try it yourself, or you can just take my word for it. Plotting points for this, other than the vertices, is a real pain. You're going to end up with square roots pretty much for every single point that you choose beyond just the vertex. Let's run the diagonals through this. If I did a decent job of plotting this, these lines should intersect at the center. Looking pretty good there. These are going to open left and right. I think Antonio mentioned that. Well done. So let's draw on this graph. And one over here. Again, just touches there. Gets close to, but doesn't quite touch the asymptotes. Finally, C was the square root of 13. So where am I going to find the foci? What would the coordinates of the foci be? Alex, where would the coordinates of the foci be?
Root 13, 0.
Nice.
Negative root 13, 0.
Yeah, so square root of 13 and 0, and negative square root of 13 and 0. Something like that. And I'll have a better graph for you on the exam because tough to try and get an idea of scale here, but that's it. Oh, there's one more thing I guess we could do. We can find the equations of the asymptotes. So we already know it's going to be y equals mx something. We just need to find the equation y equals mx. M is going to be the rise over the run. The run is the distance this way. How far am I going that way? 2. And the rise is 3. So overall, our equation is going to look like y equals 3 over 2 times x, or negative 3 over 2 times x. Beautiful. Any last comments or thoughts on problem number E here?
Could you flip back to the other thing you did?
The other page? Sure. So kind of like what we did in section 11.2, one of our goals was to rearrange these equations to make them, in more of the standard form. Now right now the center is at 0 and 0. 0 is what makes this numerator equal 0, and 0 makes this numerator equal 0. When we change things up in section 11.4, you're going to have expressions like x plus 4 squared over 5 squared minus y minus 3 squared over 2 squared equals 1. That's no longer going to have a center at 0 and 0. Where is the center of this one going to be? What would you guess? What makes the square term equal to 0? Negative 4 and positive 3. Yeah, well done. So that's going to be the big difference. So you're going to start out there. You're going to do kind of the same thing that we did here. You'd move to the right and to the left and up and down to find those points. You're just starting at this point as opposed to starting at 0, 0. So that's what's coming. Nice. All right. Let's put this one to rest.